yeah, for the let's recall it, right? For derivative, we learn the definition of the derivative as a limit. Then we use the definition to find the derivative of x squared, like 1 of x, square of x. But we do get some formulas, right? But in general, it's very difficult to find a derivative like a sine square x using the definition. So difficult, right? So we then later on we learn some formulas that help us to find the derivative. Okay, instead of find the limits, we just use formula to find the derivatives. Okay, so that's why the formula is useful. Now for integral, we will do the same thing. We begin with the definition of the integral. Okay, we begin with the definition of integral. Then we try to use the definition to find to evaluate the integral. Then later on, we're going to learn some formulas, some ideas, how to evaluate integral without using the limit. Okay. All right. So what is our definition of the integral? Okay. We got this idea from finding the area of some region and some graph. So we use the same idea. We do not assume this time. We do not assume the function is positive. The function could be negative. Okay. So we consider a function f of x on some closed interval. Okay. So it could be positive, could be. So we formally, define a Riemann sum. So we have a partition. We do the same partition, right? Remember, that's why how do we, if the function is positive, right? We try to find the area of the region under this function. So what we do is we partition the interval from A to B, okay? And in each interval, we select a point, xi star, okay? Right now, I do not assume the function is positive, could be negative, okay? Then I consider the Riemann sum, okay? The Riemann sum is the sum of this term, okay? Where, xi is going to be, delta xi is going to be the size of the interval, IC interval. So geometric meaning of this Riemann sum is going to be the area of the rectangle. Okay, the area of the rectangle. If the function is positive, if the function is negative, there will be negative area of the rectangle. Okay, so here's a let me just draw the function. It should be negative, right? So this is a xi minus 1. This is a xi, and this is an arbitrary point xi star. So, okay, so the product of this is going to be, it's negative. So absolute value of this product is going to be the area. Now, if you introduce a negative sign, you can call it sign area. So f of xi star delta xi is going to be the area. Okay, maybe I should the sign area if we allow the negative sign because it's below axis. If the sign the area of the region of the rectangle, okay, not region, okay. Okay, this is a rectangle, okay. So rectangle, the width is, the width is going to be delta xi, which is, okay. The length is going to be f xi star, but the length in this particular case is negative sign. That's what I call the sign area. Absolute value is just the area of that rectangle, okay? Because f of x is negative, and if we drop the negative sign, then this is just a positive number, which is the area of this rectangle. Or you put a negative sign, that's fine, it's a negative sign. Okay, we call the negative area of the IOG. Okay, so we can see, we add them together. Okay, add them together. Okay, add them together, I call the Riemann sum. Okay, now if this Riemann sums approach a finite number, then we say the function is integrable, and the limit is called the integral of the function of the interval. Okay, so if the limit exists, okay, if the Riemann sum, okay, approaches some number, let's call it L, finite number, okay, as all the subintervals, this approaches zero uniformly. So uniformly means the maximum value I from 1 to n delta xi, the largest one, it approaches zero. Okay, as this one approaches zero, then you have so many numbers you're going to get, right? Countable. Okay, because xi star is also an arbitrary point. But if they're, okay, this is a finite number. Okay, a finite then we say that f is said to be integrable. Okay, and L is called the integral of the function. F over the interval from A to B. Okay, and denoted by, I have to use a notation, just like the limit for the derivative, I denote by f prime x, right? F prime a. So here our notation will be like this. It's interesting. So it involves lots of things. It involves the function, of course, and it also involves the dx. So dx is like, oh, that's come from the derivative, yes. So dx, and then you have the integral symbol. This is a structured S, the letter S. S means the initial of the sum. Okay, so because this comes from the limit of the sums, right? Limit of the Riemann sums. Okay. Okay. Roughly speak, in other words, the limit of delta xi approaches zero. This Riemann sum, if it exists, it is going to be the limit, which is denoted by this symbol. Okay. In other words, if I ask you to find the evaluate this integral, and this integral is comes from the Riemann sums, okay, and its integral is going to be the limit of this Riemann sums. Okay. So question is, what is the geometric meaning of this? Okay. Well, we can look at the geometric meaning as the Riemann sum can be divided into several groups, like a Lie group. If you have A plus B plus C, you can A plus B parentheses and plus C, right? So the geometric meaning of the integral this integral, if the function is positive, right, on the interval, then this integral is just the area. Okay, is the area of the region under the function. Okay, that's the geometry meaning. So the integral is just the area of the region. Okay, if you ask me what is the integral, if there is this is just the area of the region. Okay, in this case, this graph is above the x-axis. Right, and so what happens if the function is always negative? The integral is negative sign, okay? So the integral is going to be the negative of the area of the region, okay? Above the graph. Is going to be the negative area of the region above y equals f of x. Okay, and what does that mean? That means first of all the integral is going to be negative. Okay, first you calculate the area and then put the negative sign on. Okay, it's negative of the area. Okay, negative area. Okay, I just simply call it negative area. Okay, area is always a positive number. Just put a negative sign there. So that region y equals f of x. The reason is the length is always negative, right? Negative of the length, f is the negative of the length of the rectangle. And mixture, if some x is somewhere it's positive, somewhere is negative, if fx changes signs. Okay, then the integral, for example, changes signs like that. Okay, then this you have several regions. This region has area 1, that region has area 2, this area 3, right? Has area 3. Then the integral of the function, imagine is going to be negative a1 plus a2 minus a3. Okay, we call it the signed area. Okay, the signed area could be negative, could be positive. Okay, and yeah, it depends on whether the graph function is positive or whether the function is negative. The signed area of the region. Then this time I cannot say above the graph. So between the graph and the x-axis. How about that? Okay. So there are lots of regions, right? It's determined. Some regions below the axis, so you get a negative area. Regions above the axis, you get a positive area. So add them together. Maybe that cancels out. Okay. So this is a. So that tells you if you know each region, you can evaluate integral. You don't need to take a limit. The limit is too complicated. Okay. So how about that? Evaluate the integral from -1 to 4 of x dx. Okay. All right. So let's use the above geometric interpretation of the integral to evaluate. Okay. The geometric interpret, and first of all, you draw the graph. This is a straight line y equals x, and here it is 4. That's a 1, -1, right? From -1 to 4. Okay. So there are two regions. One small region is below the axis, the larger region is above the axis. And that is going to be, if this area is A1, that's area is A2, will be -A1 plus A2. Okay. So what is the area, the triangle below the axis? With -1/2 times 1 times 1, right? The triangle above the axis would be 1/2, 4 times 4. So that would be, 8 minus 1/2. Okay, 15 over, 7.5, 15 over 2. Okay, that is the exact value of the area. Exact value of the integral. Okay, it's because some area is negative, some area is positive, then they cancel out, and you get the final result. It's signed area. Okay. But sometimes you're not able to find the area easily if the region is not triangle, right? If the region is not triangle, but like a polynomial, like x squared, right? Like an x squared. So you have to use the limit to define, but the limit in general is very arbitrary. You know, the partition very arbitrary. Okay, so it's very difficult to find the Riemann sum to simplify. So Riemann told us we just needed to use a special one. That's enough. Okay, that's the same. Riemann, the first initial is B. Okay, so this works only for continuous function. If f is continuous on a closed interval, okay, then this integral exists. Okay, in other words, the Riemann sum has a limit. Okay, and it has finite limit. So i.e. those Riemann sum from n when those Riemann sums have a finite limit. Okay, converging to a finite number. Okay. So what that tells us? That tells us because you have so many choices, partitions, blah blah, right? In particular, if you choose a special partition, okay, implies for a particular partition, it's a plus r delta x, where delta x is going to be b minus a divided by n, okay, and the xi star is going to be xi. Choose a point right end point each interval. This is a special Riemann sum. Okay, the special Riemann sum, of course, approaches this integral as delta x approaches 0. Okay, so let's understand the logic. Okay, Riemann proved that those Riemann sums, they all approach the same number, which is called the integral of the function. When the size of subinterval is getting smaller and smaller. Okay, those partitions of the interval not necessarily to have an equal size. Subinterval don't need to have equal size because this is true in general. So why not, in particular, if you choose a special, because you already know the limit exists, so you choose a special partition, equal size, subintervals of equal size, then you still should have the same limit, right? Think about that. I compare with this. So if the function, yeah, we know that as a limit as n approaches 0, x approaches 0, we know the fact, right? This is true for general, yeah, compared to the following, okay? Limit as x approaches 0, right? We know this is true, right? When x approaches 0, sine x of x is going approaches 1. But in particular, if you choose a special sequence, this implies n approaches infinity, sine 1 of n divided by n also 0, also equal to 1, right? Okay, it's the same logic. So if sine x of x approaches 1, as x approaches 0, when x approaches 0, it takes any numbers. Could be irrational number, doesn't matter. As long as it gets smaller. Then if you know the limit is going to be 1, it has a limit. Then in particular, sine 1 over n over 1 over n, right? It also approaches 1 as n approaches infinity. Okay, 1 over n is a special sequence of numbers that approaches 0, not an arbitrary x. Okay, same here. Same here. You see, for Riemann sum, your partition is complicated. It's arbitrary, right? Okay, and also xi star is in the interval. Okay, it's also arbitrary. There, but as long as delta xi is the largest one approaches 0, and it, okay, Riemann said as long as the function is continuous, then those Riemann sums approaches 0. Not because n approaches infinity, because delta xi, you have to make sure delta xi uniformly approaches 0. Okay, then and yeah, this limit is slightly different. Like you have sequence of numbers approaches to number. That you have so many, so many Riemann sum approaches some number. Then in particular, right, if you choose a special partition, if you choose a special partition, right, like this, okay, if you choose special, so that x special partition is xi minus x minus 1, it's the same. Delta x equal b minus a over n. They have all equal size. And the point in the interval will be the right endpoint, xi. Then you get a special Riemann sum. This is a special Riemann sums. Okay. Of course, we approach that number. So use that one to find the integral of the function. Okay. All right. So let's take a look at the example. Okay. Evaluate the integral from 0 to 1 to x. Let's say 3x squared dx. Just use this. Okay. So how do you draw the graph? This is a parabola like that, right? When x equals 1, the y value is 3. So this should be called the area of the function. Now I need this gives the area of the function. So evaluate, this actually is just the area, but how do you find the area, right? How to find the area? You still have to use the limit definition. So according to Riemann's theorem, the function 3x squared is continuous. So the integral exists. In order to evaluate, we just need to take a look at the special Riemann sum. When xi equals 0 plus I delta x. Delta x is the same as the size of each subinterval. It's going to be 1 minus 0 over n. It's 1 over n. Okay. So xi star is going to be xi. So the Riemann sum is going to be f of xi star 3xi squared delta x. Okay. So integral, you have to say that why you have to find the limit, right? Because by Riemann's theorem, okay, the integral from 0 to 1, 3x squared dx squared is going to be the limit of this Riemann sums, sequence of Riemann sums. Okay, and delta x approaches 0. It's the same as n approaches infinity, because delta x is 1 over n. Okay. So in order to evaluate this definite integral, you just need to find the limit. Okay. So how to find the limit? Xi is going to be I over n squared. Delta xi, it's 1 over n. Okay. Okay, so let's continue. And I think we can take 3 out. I can take it and cube out. Right. So let's look at the let's look at the sum of I squared. From 1 squared to 2 squared actually is going to be n times n plus 1, 2n plus 1 divided by 6. Okay, and this one definitely has a limit. Okay, you cancel 1 after you simplify it, and that's gonna be 3 over 6 is 1/2. Then n is gone, 1 over n. It's 2 plus 1 over n. So the answer will be what? All right. So we use the definition of the integral, almost right, to find the integral. Okay. All right. So the next one. Next one. This is y equals x cubed. Okay. Evaluate this integral from -1 to 2, x cubed dx. I think it's positive because the sign in area is going to be positive because this one and that one canceled out actually, right? So my opinion is going to be the integral from 1 to 2 of the functions the same. Okay, according to the picture, it's clearly it's going to be from 1 to 2 x cubed dx, right? Because the negative part, the positive part, those two are identical, canceled out. The sign, the area of this positive part, right? Area of minus area of this, that, this, and this part. So you can see that you don't need to. You just need to find the area of the region under the graph between 1 and 2. Okay. All right. So now, according by the Riemann theorem, this is going to be limit as n approaches infinity, sigma n from 1. Okay, and here xi cube delta x. Okay. If I can quickly get back, then we're still in the center. Oh. Right. So technology is not good enough. Sometimes the bugs in the software. It's not that stable after testing this. Where if you are familiar with the programming, any application like that, there's so many pages code. It's very complicated. Okay. I hope there's nothing wrong with that. So this is you have to, it's Riemann sum. The special Riemann sum because the function is continuous. Just write down like that, okay? Then you have to give me what is delta x. Delta x is going to be 2 minus 1 over n. It's 1 over n. And the xi is going to be 1 plus I delta x. That's it. Okay. So you find the endpoints, n subintervals between 1 and 2. Okay. Then you get the Riemann sums. Okay. Xi star, xi cubed times delta x has a geometry meaning. That's just the area of the rectangle. Okay. All right. So we put. So you get. You will get 1 plus I over n cubed 1 over n. Now the problem is this does not simplify the computation. Okay, the reason is how can I add them together, right? You have 1 plus I over n cubed. So it looks like I simplify the integral, but you end up with because xi cubed. It's not easy to simplify. Okay, so you have to expand it. It's 1 plus I over n cubed. You have to multiply this out. So I thought I can make the integral simpler, integral from 1 to 3, but turns out to be it's actually more complicated. Yeah, okay, it's more complicated. Okay, but we can do that, no problem. You know, you have to expand it. It's 1 cubed plus 3 times I over n plus 3 times I square over n square plus I cube over n cube. Okay, okay, because it's cube. Then each term 1. The first term is actually 1 of if you take a 1 of n out, the first one is just n because sum of I from 1 to n is n. The second term is going to be 3 of n, right? And the sum from 1 to 2 it's all going to be n times n plus 1 divided by 2. The third one, it's n cubed. So 1 square plus 2 square plus 2 square will be n times n plus 1, 2n plus 1 over 6. And this is going to be n square n plus 1 square 4. Okay. Yeah. The sigma I cube is going to be n times n plus 1 divided by 2, then squared. So now you simplify it. You move n into this still 1. Then you have 3 over 2. I think it's 1 plus 1 over n. And here 3 over 2 is 1/2. This is a square first of all, right now it's a square. Yeah, they have another n from outside. So you get 1 plus 1 over n, 2 plus 1 over n. Okay, then I got quarter. Okay, so finally if n approaches 0, infinity, you get 1 plus 3 over 2 plus 1/2 times 2 and plus 1/4. Let's simplify it a little bit. Let's see. You have a 1, 1, 1 to 3, and then I have 1/2 plus 1/4, 3 or 4. Okay. So this is the answer. Okay. Now some of you took calculus before, AP calculus, for example, in high school, right? Yeah. This is the best time to get associate degree from high school. I look at all the courses offered by Common High School. Okay. It's just it looks like a better than Ivy Tech. Yeah, if you take all the AP courses offered by Common High School, okay, it's a free, right? It's a free course. Don't mean to pay tuition. You can get associate degree. Looks like, okay. Yeah, AP history, AP calculus, AP economics, physics, chemistry. They are all, yeah. You can transfer credits to the college, Indiana University. Yeah. Okay, so use this opportunity to get, yeah, to save money in college. Not only save money, actually, maybe let you to even get a scholarship because you are doing so good in high school. All right, so this is yeah. If we took calculus before, now the integral of x cubed, right? Integral of x cubed. Let's do this. Either use yeah, the integral of 1 over 2 x cubed dx, right? And this is going to be x to the fourth over 4 evaluated at 200 points. Okay, that's going to be 2 to the fourth power over 4 minus and 1 over quarter. Okay, so what I got? I get the same result, right? And the 4 canceled out. It's going to be 4 minus 1 quarter. So it's a 3 quarters. Just it. But we're going to start that after on Friday. Yeah, after this class, using formulas to evaluate integrals. Okay, not limit. But still, you will be asked to use the definition of the integral to evaluate the integral. Okay, and all you have to do is just find a special partition and get special Riemann sums. Okay, and then take the limit. Okay, but if the function is a linear function, then you don't need to waste time. You can use area to evaluate the integral quickly. Okay, so here's a question from 0 to 3, 1 minus 2x dx. Okay. Okay. So how do we do that? Well, we can use a formula for this. This is gonna be sine area, right? So I know the graph. This is a 1. When x equals when x equals 1/2. Oh, I cannot draw the straight lines. If I cannot draw the straight lines, let the computer to draw it. Cool. Okay, good. All right, so this is a line y equals 1 minus 2x. Okay, it has negative slope. The y-intercept is 1. The x-intercept is 1/2. Okay, and it's between 0 and 3. So there are 2 regions. One is below the surface, below the x-axis. Okay, another one above the axis. Okay, that's called, yeah, this is a positive part. Right? So the area here is A1, that's A2. That should be called A1 minus A2. All right. So if you're able to find the area, then you solve the problem. Look at this problem, right? And this is a 1/2. So the area of the first triangle is 1/2 times the base times the height minus the area of the other triangle below the x-axis. The one side is 3 minus 1/2, right? The base, right? It's negative, right? 3 minus 1/2 is going to be 5 over 2. Yeah, 3 minus 1/2, 5 over 2. And when x equals 3, the y value is 1 minus 2 times 3. It's negative 5. So this, the height is a 5, okay? Yeah. All right, multiply them out. A quarter minus 25. It's going to be negative 24, negative 6. Okay, so the answer is 6, negative 6. But if you took, yeah, Yeah, you see when you see this side is a 5. Yeah, and here this side is 5/2. Okay, 2.5. I use the fraction here. Yeah, take the difference. Yeah, so -6. But after today's class, if you took a calculus before at IEPL or somewhere else, you know this is going to be the antiderivative, right? And evaluate the 2 endpoints. Okay, I just mentioned that. You know, it's going to be 3 minus 3 squared. That's going to be 3 minus 9. It's going to be -6. Yes, make it. It's -6. Okay. So no matter which way you're going to go, they always end up with the same conclusion. Okay. Mathematicians don't create mathematics. They only create symbols. Okay. They just discover the rules. Okay, only being there, just like some physicists do. Okay. So more you study, the less you know, because you see much wider world. You find out you only know a little bit. Yeah, someday if you have kids, you can ask them to watch some videos called The Universe. They usually enjoy watching, and meanwhile they also learn how tiny they are. Yeah, that's good. Yeah. All right, so let's take a look at the next one. Okay. Well, this one, you know, I cannot. Yeah, I can express it as a Riemann sum. Okay, it's limit of, you know, if you use a computer, how does a computer evaluate integral? Just take the limit of the Riemann sum, because computer can do that quickly. Okay, so express it as a limit of the Riemann sum. Express it as the limit of Riemann sums. Okay. Okay, so this is a, so let's express it. How do you know the Riemann sum? Write down the Riemann sum. Okay, it's a limit. So it's a limit n approaches infinity, and f of xi delta xi. So this is a Riemann sum, right? But you have to put the details there. Okay. So first of all, delta x is going to be 1 minus -1 of n, which is 2 of n. Okay. Okay. So xi is going to be the first number plus I delta x, which is -1 plus 2in. Okay, that's cool. And the function, of course, is going to be 1 of x squared plus 1, right? So now you put all the details into the function, into the function, right? Then you get limit n approaches infinity. All right, let's put the details. What is xi? Xi is going to be -1 plus 2i over n. -1 plus 2i over n squared plus 1, and the delta x is 2 over n. So who can find a limiter like this, right? It's impossible. But computer can do. Computer is so good, right? If you tell computer how to do it, computer can easily add the 1 million terms together. If you let n to be 1 million. And the fast computer, even your cell phone, the computer chips in your cell phone, probably can give the computation within 1 second. Okay, the cell phone is very fast. Yeah, the computer chip is very good right now. Okay. There are softwares much better than the graphing calculator software now available for the cell phone. All right, so I have no idea what is limit. Okay, and yeah, it's harder to figure it out. Okay. But if you think about this carefully, this is going to be 0. Okay, I claim the limit is going to be 0. How do I know that, right? I'm not a computer, but how do I know why it's 0? Okay. Yeah, you can look at this directly. Okay, but you have to write down all the terms. You find the left side, the right hand side, they all cancel out. Okay, eventually they're all gone. There's almost no term left. Maybe only the middle term. Okay, so this is going to be 0. But you can also look at the function again. Okay, this is y equals f of x, which is x over square x plus 1. What is this function? This is other function. Okay, f of negative x equals negative f of x. So how does the graph look like? The graph looks like when x equals 1, this is a 1 over somewhere here, right? When x equals 0, it's 0. So it's probably looks like that. Okay, I just draw the graph. Once you draw this graph, the other side must be symmetric, identical. So that means the region between the graph and the x-axis have 2 pieces, and they are identical. One is negative and one is positive. Okay, so this area is A1, this area is A2. A1 should be called A2. Okay, therefore the integral from negative to positive 1 is going to be negative A2 plus positive A1, that's 0. All right. So if I put this problem on the test, okay, you have 2 options. One is use the methods you're going to learn later, okay, to evaluate this integral. You cannot use the original definition to evaluate integral. You can use a substitution. Okay, I just said that if you already took calculus before, okay, and someone took it and drop it in the middle, okay, if you can all the way to this point, calculus, you probably still remember use a substitution to evaluate this integral. Okay, then you end up with 0. But also, if you recognize that this is the other function, and the interval is symmetric about the origin, as identical, right? Two sides are same. One side is negative, the other one side is positive. So from 0, -1 to 0, 0 to -1, 0 to positive 1. So, and you draw the picture, you say hey, clearly they're canceled out. Then they still get 4 credits, okay? Yeah, as long as you can point out to this. Yeah, so they're canceled out, it's going to be 0. Great. So this is but if you use the substitution, you can easily find the antiderivative of this function, okay? The antiderivative of this function will be square root of x squared plus 1. Okay, will be square root of x squared plus 1. So I just put a note here because some of you probably recognize. So the antiderivative of this function will be this. And then evaluate the 2 endpoints. And then you get you get positive 1 squared plus 1 minus negative 1 squared plus 1, which is 0. Okay, it's the same thing. Okay, but we can do that later. Then we are very curious about the area. Suppose you have a computer, right? And you want the computer as you have to write the program for computer to evaluate the integral to find area of the semicircle, right? The semicircle, you can use a limit of the Riemann sums to estimate the area of the semicircle. Okay. All right. And so now I'm going to talk about another property of the integrals. So if you have two functions, okay, one is less than the other one, and the x is over the interval from a to b, right? Okay, so you look at the corresponding Riemann sums. And you will have the same inequality, right? All right. So this is inequality, okay? And then you take the limit, okay? You take the limit. What do you get? Why this inequality still holds? Because you have same delta xi, you have them, right? Identical for the same partition. So the limit will be this, and this side's limit will be g of x, right? So you still have the same inequality. Okay, this is true. Okay, now that's the first thing. Second thing is, what's the meaning of the integral again? Let me talk about integral. Okay, so we have this inequality comparison theorem. Okay, I think it's obvious. And so uses a comparison theorem. If the function, if you know f of x, supposed to be x over square x squared plus 1, right? Okay. And I know this is going to be less than or equal to 1 for x on the interval for x in the from 0 to 1. Do you agree? Why it's x? Yeah, this is less than or equal to x equal to 1. Right? Can you tell that? Yeah, of course, that's obvious, right? So the reason is for x is positive, right? X over square x squared plus 1 is less than or equal to x over x, right? If you make the denominator smaller, you make the fraction larger. And that is going to be 1, right? Because the x is positive, which is 1. Okay? That's it. So that means, according to above inequality, it's less than from integral from 0 to 1 dx. Okay? Now integral from 0 to integral 1 from 0 to 1 is just area of the square. Because if you have a constant function, then you can easily find an area, right? So you get an upper bound. So that's very useful for you to estimate the integral. Estimate the integral. If you have an upper bound for the function, then you get an upper bound for the integral. All right. So now we assume that f is continuous on the interval from A to B. Okay. Let's look at the picture here. Okay, let's draw this, right? Then you know this is the maximum value, this is the minimum value. Okay. Here's a B, that is A. So the maximum value, absolute maximum value, I'm going to denote by F max. Okay, and this one be F minimum. So the function now less than equal to the absolute maximum value and the greater or equal to the absolute minimum value. It's between them, right? It's a number. All right, so you can put the integral on both sides. And this side, integral of a constant will be just a constant times function. And here's the integral of the constant just equal to the constant times the difference as the size of the interval. Okay. Here I'm using this property. If it's constant, just k times b minus a. Okay. The reason is if you draw, you get a rectangle. Okay. The rectangle, the width is k, the length is b minus a. It's constant. Okay. So this is a k. Here's a that's a b. The integral of the k is over the interval is actually the area of this rectangle. That's why it's a constant times b minus a. All right. So what does that mean? Great. If I divide both sides by b minus a, I get a number between. Between the absolute maximum and absolute minimum value. Okay. So the meaning of this is the average value of f over the interval. All right, so the integral of the function divided by the size of the interval is actually the average value of the function because the function is continuous. Okay. Why this becomes the average value? I will tell you the meaning of that. Okay. So look at this function. Okay, and this is right A and B. I have a bunch of points. Okay. So so delta x is a b over a minus, right? And xi is going to be a plus I delta x. Okay, what does the Riemann sum means? The Riemann sum divided by b minus a. Okay. Because delta x is b minus a over n. So this just becomes 1 over n. Why? Because delta x is b minus a over n, then divided by b minus a over n, b minus a is gone. So this is going to be fx1, fx2, and so on, right? So this is the average value of the discrete data. Okay, the value of the function at those points. That gives you, suppose you the stock price. So stock price, if you look at the graph, it's continuous graph. Okay, because every second you get a price. Every second you get a price. Okay, So, but if you want to look at the average value of the stock price over the whole year, how do you do that? Well, you can divide the whole year into 365 days. In each day, you randomly pick up a point. It sometimes change a lot, right? So add them together, n equals 365. Then you have the stock price on each day, right? Then add them together, divide by 360. You can say this is the average price, but that's not accurate enough. The reason is even one particular day, the stock price change a lot. Okay, and at what time you pick up the value, right? So the best way to do is you divide the whole year into many equal size with time intervals, as small as possible, the time interval, right? And every second is better. Yeah, every second you change you look at the value of the price of the stock. So the whole year is 360 times 24 hours times 60 minutes times 60 seconds. That's a huge number. You cannot do the computation, yeah, but the computer records the stock price every second. So you can quickly ask a computer to give the average value of this entire year. Okay. Okay. So no wonder if the limit, okay, if you look at the limit, okay, this approaches, if you just look at this, it's harder to see what is the limit, all right? But if you look at this, then the limit is going to be b minus a, the integral of the function. Okay, so that's why this is called the average value of the function. Okay, over this time interval from a to b. Okay, but why it's average value? Just look at that, because this indeed is the average value of the function at those numbers. Right, so average value. Okay, this is and we know that the average value is between the maximum value and minimum value, right? Common sense, but we already proved that average value is between minimum value and the maximum value. So because of that, and for any number, this is some number, the average value of the function, okay? Somewhere here, because this is between minimum value and maximum value. So there should be another value of c, right? So this tells us we get by the intermediate variance theorem, we can have the following property. By the intermediate variance theorem, we have f of c for some c in the interval from a to b. Okay, this is another, yeah, this is another called the mean value theorem, I think. Mean value theorem. Okay. Mean value theorem. This is another mean value theorem. Compare with the one about the average rate of change, right? We also have, we have a different one. You see, this is an average value, right? Average value is going to be the value of function at some point. Okay. And we also have another one, right? Remember that f, we call that fb minus fa. B minus a equals f prime c. See, that's different for some c in the interval from a to b. Okay. It's quite different. Okay. This is the average rate of change. Average rate of change over this interval from a to b. The difference of change at a single point, and then divided by the size of the interval It is rate of change at some times. This is the average value. It's not change the value. Average value. They're quite different. Okay. When is the average value and when is the average change? Okay. If the function represents yeah. So I don't have much time left. Let me just look at the findings. Look at the example. So f of x equals x squared, and x is between 0 and 2, 0 and 1. Okay. This is the function. So what is the average value? If this is a strict line, picture the average value is 1/2, right? So this should be less than 1/2. Okay, because it's not a strict line. The average value should be smaller than 1/2. Okay, although some place the value is greater than 1/2, even close to 1, but the average value here is almost 0. So the average value is going to be less than 1/2. Okay, by definition, find the average value of f. Okay, so average value of f by definition is going to be integral from 0 to 1 x squared dx, and here's the 1 minus 0. And we already did the computation. Okay, the integral of x squared is going to be 1/3 the integral from 0 to 1. Right. Okay, so this is a smaller than 1/2 as a predict. Yeah, so average. If we have to evaluate this by the limit, then it's going to be the limit of the Riemann sum. Okay, it is going to be xi squared. So I of n square 1 of n. Okay. The reason is delta x is 1 of n, xi is going to be I of n, so xi squared. Then add it together, and you take the limit, okay? And the limit is going to be n squared, right? N squared, n cubed here, 1 of n cubed, and I squares, add them together will be n plus 1, 2n plus 1 divided by 6. So the limit is going to be 1/3. Okay, the limit is going to be 1/3. All right, so that's all about today's